In this video, we are going to discuss non-parametric tests with the scenario Kruskal Wallis test. The Kruskal Wallis test is nothing but the counterpart of one-way analysis of variance, in which we compare the mean. In the one-way analysis of variance, we compare the means of different groups. This time, we are working with comparing the population median among more than two groups. So for example, we want to determine the opinion from patient from T hospital while asking question doctor behavior during treatment is kind. This opinion was observed in 4-point Likert scale. For example, strongly agree, agree, disagree, and this strongly disagree. So this is a kind of a ordinal variable. So ordinal variable is being compared between more than two groups, which are three hospitals here. For this scenario, we have to apply Kruskal Wallis test. In our scenario, we are going to use the HSP data in which we are going to compare social studies score between different type of program. The three different type of program in our data is general, vocation, and the academic. So first, before proceeding towards any kind of test, we have to check the what kind of variable we have. This social studies score is a numeric variable, and the program are the nominal variable with three categories. So since we have the quantitative variable in our analysis, so we will have to check for the normality assumption first. So we are going to check whether our quantitative variable, which is a social studies score, is normally distributed in each group. So we will go to analyze descriptive statistic and explore in SPSS, and then when appear, we will transfer the social studies score independent list because it is a quantitative variable and a test variable. And in the factor list, which is our independent variable, it has categories. So we will move to the factor list in this box, which is the type of program. Then we will choose the plots button. In the plot, we will have the option normative plot with test. We will press continue and we'll press OK. In the output file, we will obtain tables and a graph. We will seek for the table which has test for normality. So in the test for normality, we will see for the Shapiro test. And in the Shapiro test, we will seek the column which is significance, and we will see the p-value. So it is our assumption that null hypothesis that the social studies score in three different programs follows normal distribution. So our alternative hypothesis that the social studies score does not follow normal distribution in each program. If we see the p-value, the first p-value is 0.10, which is more than 0.05, which implies that the social score in the general program follows normal distribution. The second p-value is 0.000, which is less than 0.05, which implies that the social studies score in the academic program does not follow normal distribution. Then we have the third variable, which is 0.091, which implies that the p-value is more than 0.05. So it means the social studies score in the vocation program follow normal distribution. But since two p-values, in the social study program, in the two program follow normal distribution, but in the third program, which is in the academic program, this score does not follow normal distribution. So even if any of the category, even if we have the 10 category and nine category does not follow normal distribution, and one category does not follow normal distribution, so still we cannot apply the parametric ANOVA. So we will have to proceed for the Kruskal Wallis test. So coming towards our main example, which was comparing the writing score or social studies score in the three groups. First, we had to formulate the hypothesis. Null hypothesis is that the average social studies score in three programs are not different. Alternative hypothesis, average social studies score in three programs are different. Level of significance alpha is equal to 0.05. The statistical score Wallis test. Rejection region is not if p-value is less than alpha. Competition is given in the next slide, that is analyze non-parametric test, legacy dialog, and the k independent samples. In the k independent sample, we will transfer our quantitative variable in the test variable list, which is our outcome variable, and in the grouping variable, we will transfer our independent variable, which has the three categories, and we will have to define rate. There we have to give the minimum and maximum range of the data, and we know we have three categories, and we have given the three coding: one for the general, two for the academic, and three for the vocation program. We will give the minimum and the maximum value. We'll press continue, I will press OK, and this output will appear in the output file. And in the output file, we will seek for the sig, which is nothing but the p-value. This time the p-value is less than equal to 0.05, which implies that we are able to reject the null hypothesis that social studies score is same in the three different program, and we will formulate the alternative hypothesis. We will formulate a conclusion based on alternative hypothesis that social studies scores of student enrolled in three different programs were not same. But again, the question will arise here also, like in ANOVA, that if it is saying that all the three programs are not producing the same average, but which program is different? For that purpose, we will have to run the post-hoc analysis for the Kruskal Wallis test. In the SPSS, the post-hoc analysis is not directly available, so we will have to consult the ANOVA again. But before we proceeding to the ANOVA, since our writing score is a skewed variable, ANOVA analysis is robust with the parametric test. So first we have to do the rank the responses simultaneously. Then we run the post analysis on the rank responses as done in parametric ANOVA, and then we seek for the pairwise comparison differences. So for ranking our response variable, which is the social study score, in the SPS, we have the option of transform, and in the rank cases, we will have to provide the variable which is social studies score in the variable box, and we do not have to touch any other option. We will press OK simply. When you press OK, the SPSS will generate a new variable, which is the rank SOST. RSOST is nothing but the rank of social studies score in the last of the variable list, and then we will have to run the post-hoc analysis, like again going to analyze, compare mean and one-way ANOVA. In the one-way ANOVA, we will put the rank of social study score which was created by the SPSS while ranking the variable, not the original social study score. And in the factor list, we will give the again it will be the same as the type of program which we had chosen. And then in the post-hoc, for example, we are working with the Tukey test. We will press continue, and then we will obtain this table. Within this table, we have this column which is the p-value. And this table is basically comparing the mean difference, the mean difference of each group. For example, general to academic, general to vocation, and academic to general, academic to vocation, vocation to general, vocation to academic. So we will seek the we will seek seek the comparison. For example, the gender variable, sorry, the general and the academic p-value has the 0.001, which means the social studies score were different in general and academic program. The p-value for the general and the vocation is 0.000, which implies that the average social studies score in the general and vocation program are different. And the p-value in the between the academic and vocational program is 0.000, which implies that the average social studies score in the academic and the vocational program are different. It implies that all the groups have different social studies score, and this is the outcome from the pairwise analysis. Thank you.